Okay, guys, chapter 1, section 2 is functions. Again, this is review kind of stuff, so if I'm boring you, I apologize. If you don't remember this, no worries. We're going to get it back in our brain now. A function. Something is or isn't a function. You guys have talked about this probably a little in geometry. I know in Algebra 1, but a rule that assigns each element x in a set A to each element in a set y. That doesn't mean anything to you. I understand that. When you have something that is a function, for every x value, there is a y value. When you have points, what does it say right here? No x can what? Make sure you pay attention to that. If I give you a set of points, ordered pairs, the only thing that matters is the x values. If something is a function, then no x's are repeated. If x's repeat, it's not a function. If you have an equation, and I give you just a random equation, I say, is this a function or not? You have to pay attention to these two things. Y cannot be raised to an even power or be an absolute value. You have to memorize those things. When you were in middle school, you might have had a function. They'd give you something like this. Draw your order. And then they say, is this a function? You guys would use something called the vertical line test or the pencil test. What would you do? Anybody remember?
I think you pass through it.
Correct. You put a vertical line. If the graph only touches the line one time, then yes, it's a function. So if I go here, it only touches once. At any point on my red graph, if I put a vertical line, how many times will it touch that function? One time. What is the equation for a vertical line? X equals or y equals? X equals. So that correlates to, if you have an ordered pair, x's will not repeat because it only touches one time. So visually, that's how you tell something's a function or not. By a graph, if you just put a vertical line, if it touches once, you're good. But if I give you a set of ordered pairs, x cannot repeat. And if I give you an equation, y cannot be raised to an even power or be an absolute value. So if you have something like this, determine if this relation is a function. If you have a set of points, what did I tell you is the only thing that matters? The x. Look at my three x's. 2, 3, and negative 2. Are any of those the exact same number? So yes, this is a function. What about B? 2, 3, 2. No, it's not. Why? Because 2's repeat. The only thing that matters in an ordered pair is what? The x. If I give you an equation, what are the two rules for an equation we just talked about? Has to do with what letter?
Y.
Y, and they can't be what?
An even.
Raised to an even power or in absolute value. So look, don't even look at anything else other than the y's. In letter C, is y raised to an even power or in absolute value?
No.
So is this a function? Yes. Yes, sir. The only thing that matters is y in an equation.
What is it? What do you mean?
In letter E. Do you see how y is inside of an absolute value bar?
Oh, okay.
Mm-hmm. Like visually, if you see it
Okay,
inside.
okay.
Mm-hmm. Yes, sir.
Okay, wait, so if any of those three numbers are the same, like
For the x value.
for the x value, then it's definitely not.
Correct. Mm-hmm. Because the reason why, guys, is because remember I just talked to you about the vertical line test, right? If something is a function, it can only touch one time. If I were to graph 2, 5, so say 2, 5 is, say this is 5. This 2 and 5. So 2, 5, point there. And then 3, 5, so I went over 3 and up 5 here. And then my other point is at 2, 6, so here. Do you see how these are on the same line?
Yeah.
So that's why. If you have a set of points, x cannot repeat. If you have an equation, you look at y. So on D, I'm looking at y. The two rules are it's raised to an even power or in absolute value. It's not a function. Y to the fourth is what?
No.
It's no, because that's an even power. If you have a question like this on your test or quiz, I'm going to ask you, Why? What about E? Why is it no? Good. It's a very easy concept, but it's also really easy to mess up. So just make sure you guys are practicing. All right, if you're evaluating, the word evaluate means figure out the answer, right? If they say evaluate for the given value, all you're doing is plugging in the value for the variable that they look at. So if I look at this first one, they gave me the function, all right? This is in function notation. What is f of x the same thing as saying? Y, right? So this is just in function notation. This is f of negative 3. What they mean is take negative 3 and plug it in everywhere you see a what? An x. So guys, this is negative 3. Remember we talked about negative numbers. They're sad and they need a hug, right? So when I plug this in, I'm going to say negative 3 squared minus 1. Very, very basic work. I understand that. What I need to see from you guys is this first step. If you skip down and say, what's the answer?
4, 6, 9.
It's 8. If you just write this first step, that's a good try. Write this first step and then tell me the answer is 8. That's okay. I need to see, though, this first step, that you understand what you're doing. But if I evaluate this, guys, negative 3 squared is 9. 9 minus 1 is 8. So you would write your answer as f of negative 3. When I plug in negative 3 to the function, what do I get out? 8. That's how you write your answer. That's how you write your answer. It's okay. You guys are fine. That's how we write our answer. You do not just write 8, or you have to write the whole thing. When I plug in negative 3, 8 is what I get out. So let's do the second one. Evaluate. Figure out what the answer is. I'm going to say 2 squared minus 1. Well, 2 squared is?
4.
And 4 minus 1 is?
3.
So I would write my answer as f of 2. When I plug in 2, what do I get out?
3.
Perfect. Look at C. Am I plugging in just a number for C? No, I'm plugging in an expression. No different. Instead of x, I'm plugging in a plus 2, and I square it, minus 1. What does that mean, a plus 2 quantity squared? Not distribute. A plus 2 times a plus 2. You're going to have to FOIL. A plus 2 times a plus 2, and you still have that minus 1 at the end. So when we FOIL, a times a gives me a squared. A times 2 is 2a. 2 times a is 2a. And then 2 times 2 is, and then I still have my minus 1. Now you simplify, guys. Combine like terms. Can you combine anything with a squared? No, so you just have a squared. If I have 2a and 2a, that gives me 4a. And then 4 minus 1 is? So how would I write my answer? Okay, a squared plus 4a plus 3. But what do I write at the beginning?
F
Good.
of 2, a plus 2.
F of a plus 2 equals, because you're telling me when I plug in a plus 2 for my x value, a squared plus 4a plus 3 is what I get out. Does that make sense? Okay.
You go back and
What's up?
So I guess will there be scenarios where
Either one. You got it, Sean?
So you do it like that. And you
Mm-hmm. All right, guys, piecewise. A lot of you, I know you've seen this in Algebra 2, and I know when you did it, it kind of goes over some of your all's heads. Piecewise. Think of the word piece. If you have a piece of something, do you have the whole thing? No, you just have a piece. We're going to talk about evaluating piecewise, and we're going to talk about graphing them. Evaluating them is not that difficult. Graphing them isn't either, but it just takes a little bit of brain power. So if I look at this, it says evaluate each piecewise to find function at the indicated values. First of all, the word evaluate means to do what? Solve. Figure out the answer. Plug in. So they gave me two expressions, x squared and then x squared plus 2. But they gave me what's called restrictions. These are my restrictions or my parameters or however you want to call it. I'm going to use the x squared expression if the number they want me to plug in is what? Less than 0. Do you guys see that? How it says x squared if x is less than 0. So if they give me a number to plug in and it's less than 0, I plug it into the top one. The bottom parameter or restriction says x squared plus 2 if x is greater than or equal to 0. So if the number is 0 or bigger, I plug it into which one? The bottom one. Does that make sense? You guys understand what I mean by that? So the first thing you need to do is figure out which expression you're going to plug into, and then you figure it out. So I'm going to look at A. A says f of negative 2. Well, look up at the problem. Look at your given expressions. Negative 2. Is negative 2 less than 0 or greater than or equal to? It's less than. So which expression are you going to use? The first one, x squared. So you would show me, hey, I understand. I have to plug it into x squared. And then when you do, you'll say negative 2 squared is what? 4. So you would say f of negative 2 equals 4. You don't plug it into both. You only use the expression that the number that they give you falls into. It's like the next one. F of 0. Well, think about it. 0. Is 0 less than 0 or is 0 greater than or equal to? Greater than or equal to. So which expression am I going to use? The second one. Good. So I have x squared plus 2. Show me you know which one to use. And then show me real quick the work. What's 0 squared? 0. So I have f of 0. When I plug 0 in, what do I get out? Perfect. Good job. Tell me.
Why was the first one? Why did the first one have to win that one? It's less than 0.
Negative 2.
Negative 2 is less than 0. The value, not the answer. Good question. You look at the value that they want you to plug in. If the you got to figure out where the value falls into the parameters.
I get you.
So like 3. On this one, Julian. 3. Is 3 less than 0 or is it greater than or equal to?
It's greater than
It's greater. So which expression am I going to plug 3 into?
x2.
Good. So I'm going to say x squared plus 2. And then you guys show me, okay, 3 squared plus 2. Well, what is 3 squared?
9.
And 9 plus 2 is? So when I plug in 3, what answer do I get out? There you go. We okay? Okay. Find the values of the function such that f of x equals 0. All that means is set the equation equal to 0 and solve. That's it. I want to give you guys a little hint here. All right. Look at the exponent. What's the biggest exponent on each x? And that'll tell you how many answers you're going to have. And letter A, what's the greatest exponent? What's the biggest number that you see there? How many x's are there? On the exponent. The exponent. The exponent. 1. That's a coefficient, guys. The greatest exponent is 1. So how many answers are we going to have for letter A? 1. Okay. And B, what's the greatest exponent? 2. So how many answers am I going to have? 2. What about in C? 3. So when they tell you to find the values of the function such that f of x is 0, all that means is, okay, cross this out, change this to a 0. How would I solve this equation? 0 equals 14 minus 2x. What do? We do what? Okay, we can subtract 14 from both sides. So I have negative 14 equals negative 2x. Then what? Divide by negative 2. So x equals 7. Can I check this to see if I'm right? Yeah. If I plug it back in, what's 14 minus 2 times 7? 0. All right, let's get over here. Does anybody remember what this is called if it's x squared? It will make a parabola, but this is our quadratic. When we have a quadratic, what do we have to do? Begins with an F, and we all love it. Factoring. Factoring never, ever, 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 ever goes away.
What about the quadratic formula, though?
You can use the quadratic formula for any quadratic, but if you can factor it, it would be a lot faster. All right, so f of x, I change that to a what? A 0. You can rewrite it if you want, or you can just do that. I don't care. Now, how do we factor?
Gives whatever adds up to 5.
Okay, we want to find out what multiplies to give us this number and adds to give us the middle one, right? So let's think. 7 and 2, agree. I have x in the front of both. 7 and 2. I want a negative 14 when I multiply, and I want a negative 5 when I add.
Plus 7. I know. Negative.
Minus 7 and plus 2. Good. Now we're almost there. Some of you can look at that and tell me what x equals what? X equals positive 7, x equals negative 2. Some of you can just look at that. Some of you can't, you don't remember it, that's fine. That means we have to solve each equation. X minus 7 equals 0, x plus 2 equals 0. Well, I'm going to add 7 to both sides. So I get x equals 7. Subtract 2 from both sides, and I get x equals negative 2. But at the beginning, what did I tell you? You can tell how many answers you can have, right? We started off with a quadratic. You said we were going to have 2 answers. How many answers do we have? 2. Could you go back and check this? Yeah. Anytime you have an equal sign, you guys can go back and check. I suggest that you do. But you would just plug 7 in. 7 squared. So 49 minus 35 minus 14, 0. Plug in negative 2. Negative 2 squared is 4. What's negative 5 and negative 2? 10. So 4 plus 10 is? 4 plus 10? 14. 14 minus 14 is? There you go. All right, so the last one. We're solving. What do I change f of x to? 0. So here we go.
So you have to factor this.
Hold on, not yet. Can't factor yet. I got to get rid of that 5. How do I get that 5 to go away? Okay, I'm going to multiply 5 on both sides. So 5 divided by 5. Okay, fine. 5 times 0. So I'm left, guys, with x cubed minus 2x squared minus 2x plus 4 equals 0. We're going to do an entire chapter on just quadratics and factoring and stuff. But hopefully we remember some of this from last year. If you don't, let's get to learning. All right, first thing we look for when we factor, you guys should think GCF. Is there a greatest common factor? Is there a number or a letter in all 4 terms?
Yes.
No.
No.
There's no 2 in the front. Then I look and I say, is this a trinomial?
No.
No. It has 4 terms. Does anybody remember what we do when we have 4 terms? Group it. Good, Sierra. So I'm going to group the first 2. I'm going to group the second 2. And look how I included that negative. Always do that. Then you won't have to worry about signs. So look at each parenthesis separately. X cubed minus 2x squared. What does x cubed and minus 2x squared have in common? X squared. So if I factor out the x squared, if I divide this by x squared and I divide this by x squared, what am I left with? X minus 2. Does everybody agree? Okay. And then I look at my second parenthesis, negative 2x and a positive 4. What do they have in common? What kind of a 2? Let's take out that negative. Oh, wait, if you can take out the negative, take out the negative. So if I divide this by negative 2, I am left with x minus 2. Do you guys see why I took out that negative?
I just gotta tell you.
Oh, God.
Like, I just see learning going on. I'm like, wow. Like
I should have kept the video going. Oh,
Yeah, Mr. G.
oh, Mr. Jacoby. Saturday night, I went to Jenny and Todd's, and I met his parents. They're so nice.
Really?
Yeah, but I was telling them, I said, oh, yeah, I teach with Joel. They're like, no, he's the nicest. So, but they got engaged. Did you know?
I didn't know.
Yeah, they got engaged last weekend, so they're going to get married in April.
Got first year I taught 1989. Crazy.
I was only 9 years old. Todd's old.
Yeah, he was 17. He was on quarterback. Blocked everything.
I'm the quarterback now, Mr. G.
What do you not do? My goodness.
I'm
You're
the
just all
quarterback.
over the place.
I'm the quarterback. What you talking about? I'm a Cam Newton quarterback. I run the ball.
Oh. Cam Newton,
He's my favorite now. He's my favorite.
Good move, Cam
Bye. Oh my God, he's the nicest person ever. Oh shoot, I might have kept it going that whole time. Oh, this one might be fun to watch. If you guys, now that we're here, what do you notice? The x minus 2. You have it how many times? Twice. Okay. When we factor, we always take out the GCF first. So what's the greatest common factor of this term here and this term here? X minus 2. So we're going to rewrite it one time. That's where a lot of you guys get stuck. You think you want to write it twice. We only write it once. That's our GCF. And then whatever is left over gets what? Its own parenthesis. So now we're going to find the values of x. Now again, don't get all upset or anything. This is a little different from what you guys are probably remembering. What's up?
I'm just trying to remember, where does split in the middle fit into all of this?
Excuse me? It's a factor. It's like a puzzle. Okay, how do I solve? How do I get x equals? What do I do with each parenthesis? Okay, set them equal to 0. Good. So I have x minus 2 equals 0. X squared minus 2 equals 0. So on the left-hand side, what am I going to do to get x by itself? I'm going to add 2. So I have x equals 2. Agreed? And then on the right-hand side, what am I going to do? I'm going to add 2. I get x squared equals 2. Am I done? What do I have to do? Take the square root. Guys, when I physically put the square root on, what goes in front of my answer? Plus or minus. How many answers do I have? 3. I have x is 2, x is positive root 2, and x is negative root 2. We'll talk about this later, but if I was going to graph this, how many times do you think this graph would hit the x-axis? 3 times. Your solutions, your x values, are your zeros where it crosses the x-axis. All of this comes together, and it's just amazing.
Where's the third one?
Because I have positive 2 and I have negative root 2, or plus or minus. Good question. Scooting along. If you have equivalent functions, guys, what does the word equivalent mean? Equal. So if they talk about equivalent functions, all you're doing is setting each equal to each other. That's it. So in this case, it says find the values for which f of x equals g of x. I know that looks weird, and you guys are like, wait, what are you talking about? All that says is f of x equals g of x. You see that? So set f of x equal to g of x. Now what? Okay, sorry, we're back. What do I do now, guys? How do I solve this? You are correct, my dear. How come?
Because you don't want to make the x to the second negative. You'd rather put the...
Okay. How come I can't just solve it, like get x by itself? Because why? Because there's an x squared. There is an x squared and an x. Those are not the same thing. So we have to move everything to one side. So I'm going to move this over here and this over here. So I have x squared. When I move to the other side of the equation, you guys agree that I have negative 2x and I have a negative 8? And then what do we get to do?
Factor.
Yeah, we get to factor. What are the factors of negative 8? That when I multiply, I get negative 8, but when I add, I get negative 2.
4 and 2.
4 and 2, I agree. So x and x, 4 and 2. But I need a negative 8. That means one of the factors has to be negative. And when I add it, I want to have a negative 2. Minus 4, positive 2. So what are my x values? 4 and negative 2. Okay, I might repeat myself on this, but we have x equals 4 and x equals what? Negative 2. Good. Very good. So at that point, those 2 points on the x-axis, if we were to graph this, those 2 graphs would end. All right. This is not crazy hard, but it is a little confusing, so let's just look at this. This is a very important slide. You guys are going to have to go back and refer to this. When we talk about domain is what value? X or y? X values, okay? Domain is our x values. A domain of a function is all real numbers, which means I can use anything in the world negative, anything in the world positive. Okay, if I just have f of x equals x cubed plus 2x squared plus 3x minus 1. And it says, what's the domain? There are no domain restrictions for this. I can use anything in the world, negative, positive, I'll get an answer. When you have certain situations, that's the only time you'll have domain restrictions, and that's what we're going to talk about here. First of all, if I said, what is the answer to this, what would you guys tell me?
0. Undefined.
Undefined. Correct. You cannot have 0 in the denominator. Cannot. You go to jail. Cannot. It's against the law. Math jail is probably the best place you guys would ever want to go in life. You just factor all day.
No way.
No, not for real. But no, you cannot. 0 in the denominator. No bueno. Undefined. So when we're looking at this, your domain restrictions all are going to have to do with either denominators or square roots. Do you guys see this number right here? I mean letter. What is that? It's called the word. Do you guys see that word right there? Real. If I asked you what the answer to this was, what would you tell me? It's not real. It's imaginary, right? So if you have a situation where you have a variable in the denominator, which could possibly make it 0, or you have a variable underneath a square root, which could give you an imaginary answer, that's when you have domain restrictions for a function. Any other time, you're perfectly fine. So this is like super important that you guys pay attention to this slide. You might want to like copy it and put it on your homework, that sort of thing, just so it's right there next to you. If there is a variable in the denominator, just a variable by itself, in order to get the domain restriction, you set the denominator not equal to 0, and I'll explain why in a second. If there is a variable underneath a square root, you set the expression under the root greater than or equal to 0. You can take the square root of any number that's positive and 0. What's the square root of 0? 0. If there is a square root and it's in the denominator, you have to set the expression just greater than. Does anybody understand, or can you figure out why? Why, if it's just a regular square root, like square root of x plus 3, why is this greater than or equal to 0? And why is this just greater than? The top one is greater than or equal to.
Because in the bottom you can't add anything.
Correct. Very good. You can take the square root of 0. What is it? 0. So if this bottom was 0, is that okay? No. So let's look at some of these examples. All I want you to look at is square roots and denominators right now. If I had just plain old 3x, if all I had was this, what's my domain? What could I plug in? Anything. All real numbers. Anything positive, anything negative, you could get an answer here. But I have a domain restriction. Why do I have a domain restriction? Because there's a what? There's a variable where? In the denominator. So look back at your notes that I just gave you. If there's a variable in the denominator, not a radical, if there's a variable in the denominator, what do I have to do? Not equal to 0. The reason you say not equal to is because we don't want the denominator to become 0. So I'm going to say x plus 1 cannot be 0. And now you just solve like you would a normal problem. X plus 1 cannot be 0. So what would I do to both sides? Subtract 1. So what value can the denominator not be? Negative 1. Think about that. If I plug in negative 1 for x, what's negative 1 plus 1? 0. So your answer for A would be, you would say, you can use all real numbers. You can write all real numbers if you want, or just make an R with an extra line. So it's all real numbers except what?
Negative 1.
Good. Now, this is not a concept that you guys cannot wrap your head around. It's just a matter of remembering what's what. That's all it is. Just practicing. So in this case, I'm going to look and I say B. Okay, B. Look back at your slide that has the rules on it. What's going on with B? It's a square root. Is it in the denominator? No. So I know that expression has to be what? Greater than or equal to 0. It can be any positive number or 0. So if you're going to solve this, how do you get a square root to go away? Square both sides. So I have x plus 3 has to be greater than or equal to 0. Now what? Minus 3 from both sides. So in this case, for b, x has to be greater than or equal to what? Negative 3. You can just leave it like that, because you don't have to say all real numbers, except you're saying right there the value. Now think about it. Take negative 3 and plug it in. What's negative 3 plus 3? 0. Can you take the square root of 0?
Yes.
Yeah, you're good. So you can use any number that is negative 3 or bigger. Again, we're just looking at denominator, that sort of thing right now. Look at C. What's the problem with C? You got a square root where? In the denominator. What do we know the denominator of a fraction can never, ever, ever, ever be? 0. So in this case, I'm going to say, okay, the expression x plus 4 has to be what? Just greater than 0. How come it can't be greater than or equal to? Can't have 0 in the denominator. Good. I know I keep repeating myself. That's my point. I want you guys to go to bed at night and just be like, oh my gosh, I can't get her out of my brain. That's fine. It's helpful on a test. All right, if I solve this, what do I do to both sides? Square it. So x plus 4 greater than 0. Now what? Minus 4 from both sides. So x has to be greater than negative 4. Does that make sense?
Yeah.
Okay. What about D? What would I do? I'm just don't even worry about that. Just worry about denominators right now.
It has to be greater.
Got to be greater than 0. Good. So you would say 2x plus 1 has to be greater than 0. It has to be greater than because 0 can't be in the denominator. So we square both sides. 2x plus 1 greater than 0. 2x greater than negative 1. X greater than negative 1/2. Agreed? Okay. All right, next thing we're going to talk about is the difference quotient. This at first is going to be like, what? I will do a couple of these, I promise you, before the test. We'll practice these. It'll be on your homework and stuff. This is the difference quotient. Doesn't mean anything to you right now. I understand that. Still doesn't mean anything to you. I understand that. Let's do a problem. Still doesn't mean anything. Here we go. What this is telling you, find the difference quotient. You use this in calculus. Some of you will never see this again. That's fine. That's why I'm just going to go bare minimum of getting through this so you understand the mechanics of how this works. What they are asking you to do is to do 2 evaluations. What do they want you to plug into the function the first time you evaluate?
The x.
What do they want you to plug into the x? Right here. What is that? What does that say? 2 plus h. Then they want you to do what? Plug in 2. That's all we're doing. It's going to look a lot weirder than it is, but to evaluate this, okay, everywhere I see an x, I'm going to plug in 2 plus h. So watch. I have 2 plus h squared minus 3 times 2 plus h plus 1. Does everybody see that? All I did was just plug that in. Then they want me to do what? What sign? Minus. And then what do they want me to plug in?
2.
So look, I'm going to put this in parentheses. So I have 2 squared minus 3 times 2 plus 1. All over what letter? This is the way to do this problem every single time. I'm not going to give you anything that's any more difficult than just this. This is the basic. Your friends that are in pre-calc analytic and pre-calc honors advanced, they're going to do stuff a little more involved. This is the basic of what we're going to do. All you do now is evaluate. And if you do this correctly, everything will cancel out nice and pretty. Watch. Okay, so watch. We're going to do this, and we're going to take our time because there are so many places to make mistakes, but you guys are going to get this, and we're going to practice this more, I promise. But let's just write this out. 2 plus h quantity squared just means 2 plus h times 2 plus h, right? Okay. Then I'm going to distribute a negative 3. Do you guys see that? So I have minus what? 6 minus what? 3h plus 1. We good? Okay. I'm going to treat this like two different things. I'm going to keep this all together. Then I have a minus sign. And you can do all of this here if you want to. What's 2 squared? So 4 minus 6 plus 1. Agreed? What's 4 minus 6? Negative 2 plus 1 is what? Negative 1. You can do that, guys, every single time. The first part will be yucky with letters. The second part will just become a number. It is important, super, super important that you keep the second part in a parenthesis because that middle sign of minus is going to change everything. And all of this is over what letter? H. Okay, now we're just going to simplify further. All we're doing is just simplifying. If I have 2 plus h times 2 plus h, we're foiling. What's 2 times 2? Plus 2h plus, good. Agreed? Minus 6 minus 3h plus 1. You guys with me?
Yep. So,
It's just gross. All of this is still over what? H. Okay, so now let's just clean it up. Start with your highest exponent. What's the highest exponent you see?
2.
H squared. So is there anything to combine with h squared? So h squared. That's gone. Now combine like terms. 2h and 2h is 4h minus 3h is positive or negative? Good. What's 4 minus 6? Negative 2 plus 1 minus 1. And then what happens here? Minus the negative becomes? And all of this is over what? H. Yes, sir.
So you read it in descending order of exponents?
Always. Can I do any more simplifying there?
Yeah.
What?
1.
Negative 1 and positive 1 is? Wait. Don't go anywhere.
0.
Negative 1 and positive 1 is 0. Okay, now look on top. Wait. Look on top. What do they have in common?
H.
So if I take an h out, I'm left with h plus 1, right? Divided by h. What happens to my h's? They cancel out. So your answer would be h plus 1 equals 0. So h equals negative 1. We'll talk about this more.
Where did the plus 1 come from?
Because I divided out h squared plus h. I divided out an h. So I have 1. Yep. Anything divided by itself is 1. We'll talk about this more, but it'll always end up nice and pretty like that. And we'll finish it. We'll do another one tomorrow.
Bye, Miss Barbara.
Okay, bye guys. Love you.